Today I'm just going to quickly review the information about systems, and as you know, a system of linear equations is two or more linear equations, and today we're going to focus on three equations with three variables. Okay, as you know, the solution is the intersection of the equations. That's a point x, y. For today's case, that's going to become x, y, z. If you have a consistent system, that means there's at least one solution. And inconsistent means there's no solution. Okay, just so you are aware, a consistent system could have all solutions. So it is possible that that's something as well. And then we have dependent and independent systems. So if they are dependent, that means they're equivalent equations. Okay, so essentially the same. And then independent systems mean that you have unique equations. All right, so today we're going to focus on a 3x3 system, which means three equations, three variables. So hopefully you had a chance to practice today with the 2x2 systems, which is two equations, two variables. And there were two methods, or three methods if you count graphically, for solving a 2x2 system, which was the elimination method or the substitution method. When it comes to a 3x3 system, we typically use the elimination method. So my recommendation is to pick a variable and then try to eliminate it. And I usually try to pick one that has opposite coefficients. So in this particular case, I would personally probably pick the y variable. I like to number the equations, so I'll usually number them 1, 2, 3, and then I'll focus on each of those independently. Sometimes you'll see them labeled as A, B, C, whatever's comfortable for you. And then what you want to do is you want to pick two of the equations, eliminate the variable, then pick two separate equations, eliminate that same variable, and then you're down to a 2x2 system, just like what you're used to from earlier math courses. Okay, so I'm probably going to pick number 1 and number 2. I'll do it. And then I'm just going to combine these, so using that elimination method, right? So if we combine, we have x plus 2x, our y's are gone, and then we have a negative 2z and a positive 4z, which will give us positive 2z. And then we have negative 11 plus 15. Okay, and so what I've done is I've created equation number 4. Then I'm going to pick two different equations from the original 3. I'm going to pick number 2 and number 3 because they have opposite y's. The trickiest part sometimes is making sure that you are copying them down carefully, including their signs, so that you have accurate answers. So then I'll go ahead and do the same thing. I'll combine them, 2x and 3x. My y's are again eliminated, and then 4z and negative 6z, and then 15 minus 35. So, equation number 5. And so now I can take equation 4 and compare it with equation 5 and solve that using one of the traditional methods that we've talked about. Now this happens to work out really, really nicely in that the z's already have opposite coefficients, so they can be eliminated quickly. That will not always be the case, and you'll see today as or tomorrow in class as you're practicing, that won't always happen. But in this case, it's fairly convenient that they canceled. So now I've found one of the pieces of my solution. So I've solved for x. Now I'm going to take that x and substitute it back into either equation 4 or equation 5, whichever you would like, your choice. Okay, so I'm going to sub that in to, I guess I'll sub it into equation 4. So I have 3, and now I'm subbing in that negative 2. My goal is to find or solve for z. Okay, so I have my negative 6 plus 2z is equal to 4. and then I have 2z is equal to 10. Therefore, z is equal to 5. Okay, so there's the second part of my solution, and then this is 3 equations, 3 variables, so that means I need to solve for the third variable, and the way that I do that is I take x and z and I plug it into any one of the original 3 equations, and it's your choice, whatever you would like. So I guess I'll just sub it into the first one. So I have a negative 2 plus y, because that's what I'm looking for, minus 2. I'm going to sub in what I just found for z, so in this case that 5, and then I have equals negative 11. Okay, and then we can go ahead and solve for that. So I have negative 2 plus negative 10, so I have y minus 12 is equal to negative 11, and so therefore y equals 1. Okay, and so now I've found my final solution, which in this case is x, y, and z. And so I would express my solution or write it as a coordinate, in this case an xyz coordinate. Then of course I would encourage you to check your answers, and the easiest way to check it is on the calculator, and I'll show you how to do that. So a calculator page, everything useful for our purposes is in the menu, and we're going to go under algebra, and you'll see that there is solve system of linear equations, and that's what we're dealing with. We're just going to change that 2 to a 3, and then as soon as you hit tab, it'll make it an XYZ immediately, so you can go ahead and hit OK or enter. And then you're just going to enter each of the equations that we just looked at. So you'll enter in your x plus y minus 2z. And you have to put in the equals because you have to enter them as equations. So equals negative 11. We'll put in the second equation, in this case 2x minus y plus 4z equals 15, and then enter the very last equation, 3x plus y minus 6z equals negative 35. And then once you have 3 equations entered, you just go ahead and hit enter, and it'll confirm your solution, negative 2, 1, and 5. So obviously this is just an option for checking, but it's a good way for you to make sure that your answers are accurate.